Hi, my name's Dana Humphrey. I'm Dean of Engineering at the University of Maine. Welcome to this virtual tour. We do these tours every other Thursday at 3 o'clock. We're starting on the site of the Furlan Engineering and Design Center. I'll say a little bit more about that in just a moment. I do want to say something about the College of Engineering. We have 11 different engineering and engineering technology majors. We're the kind of university where we're big enough that you have a lot of choice, but you're small enough that you're going to know your faculty on a first name basis. I had an email yesterday that made me very, very happy. One of my former students, I will have his son in class this coming spring. That's the kind of place we are at the University of Maine. We're all a really big family. So I said we have 11 different engineering and engineering technology majors. We have a lot to pick from. We have civil engineering, mechanical engineering, electrical engineering, computer engineering, chemical engineering, biomedical engineering, engineering physics. Then we have 4 technology degrees. We have construction engineering technology, mechanical engineering technology, surveying engineering technology, and electrical engineering technology. So I said we've got a lot to pick from here. No matter which one of those 11 majors you pick, we are a very hands-on program. You're going to start in your major with a course in the very, very first semester. And that's what's the way it's going to be throughout your entire time at the University of Maine. When you get to be a senior, you'll do a senior capstone project. You get to actually take and put what you've learned into real practice. Now let me say a little bit about what's going on behind me with the construction site. This is the site of the Furlan Engineering Education and Design Center. This is a $108,000, $78 million building. Some of the things that are on the first floor is actually what's right behind me in this area right here. This is going to be the Student Project Design Suite. You'll be assigned a workbench for a semester or a year with yourself and your teammates. That's going to be your space where you can take and work on your stuff. And the workbench area is surrounded by shops. We have shops for biomedical engineering, electrical engineering, 3D printing. We have a tool crib, a vehicle shop, a metal shop, a wood shop, and a composite shop. So to go out to the appropriate shops, take fabricate components, and then come back to your workbench and put them together. You're going to take and debug it. Just for your future engineers, just to let you know, the first time you turn on a new device is not necessarily going to work. It's going to be the best space of its kind in the Northeast. We're going to have it here at the University of Maine. Other things on the first floor, we're going to have our student commons. This is going to be the gathering place for all engineering students. We have food service available. This is going to be the place where you're going to hang out. We have 12 team meeting rooms that you can take and actually go on the internet and sign out for, so you can work on your classmates on projects, homework problems, and things like that. We have collaborative classrooms on every floor of the building. We'll sit in small groups and work on your projects. Second floor of the building has a lot of mechanical engineering, and then the third floor of the building is biomedical engineering, where we have our biomedical medical engineering faculty. This is going to be an awesome, awesome building. And a little bit more about what's happening on site today is you've got the perimeter foundation wall that I'm standing right in front of here. Background, you can see some of the structural steel is started to be placed. That's actually over a basement area, a mechanical basement that's not publicly accessible space. The really exciting thing that's going to happen here is tomorrow, they're going to take and move in a very large lattice crane so they can place the rest of the structural steel. And actually what they're working on down there at the far end, and we'll walk down there in just a little bit, they're actually making a gravel pad to put this really, really big crane on. This project is well underway. It will actually be completed in the summer of 2022. So for you folks that are now seniors in high school, you're going to be coming to the University of Maine to study engineering. when you come back here for your sophomore year, this building is going to be done. You're going to have access to this absolutely incredible facility. So with that, and the final thing I'd say is, okay, you graduate with your UMaine degree, then what? We have a 99% placement rate for our graduates. Actually, the last survey we did, it was actually 100%. But the number I'll say is we've got a 99% placement rate for our graduates. So you're going to be prepared to enter the workforce and with a great job. I'd now like to turn the camera over to Brittany. Brittany is with the, come on over here, Brittany. Brittany is from the UMaine admissions office, and she's going to tell you a little bit more about getting admitted to the University of Maine. So Brittany, I'll turn it over to you.
Thank you, Dana. Hi everyone, my name is Brittany Hopkins. I'm an admissions counselor in the admissions office here at UMaine. I've been working at UMaine for 4 years now. I absolutely love it. On behalf of the whole admissions office, I'd just like to say we're so excited that you are interested in UMaine and specifically the engineering department here. It's one of the best and brightest that we have on campus. Lots of cool things going on, as Dana mentioned. Even outside of the academics, here on campus at UMaine, there's so much to do, so much to get involved with outside of the classroom. We're the only Division I sports program in the state of Maine. So for any of you that are interested in playing a sport, whether that's at the Division I level, at the club sport level, or just intramurals for fun with your friends, you can do that here, as well as 200 plus other clubs and organizations. Whether you want to be part of our Greek life organizations, maybe the president of our student government organization, or even if you want to be in our competitive men's and women's lumberjack team, you can do that. We cover a wide range of interests here. No matter what you want to get involved with, you can do that here at UMaine. You also get the chance to live in beautiful central Maine. We have our harbor in Acadia National Park, only about an hour away from campus. You get to see the ocean and the coast of Maine if you want to in just a little drive. You can go to western Maine, go skiing, snowboarding at Sugarloaf or Saddleback Mountains in a couple hours. You can even take a couple hour drive north and go to Canada if you'd like to. It's awesome. There's lots of stuff to do. Even in Orono, where we are in Maine, you can go to downtown Orono and go to a small coffee shop, get pizza at Pat's Pizza. There's lots of stuff to do. From the admissions perspective, I'd like to just go over quickly what we'd want to see if you do decide to send in an application here at UMaine. Of course, for our seniors that are logging in, if you are aware, we just had a deadline pass, our early action date. That is non-binding. If students applied that way, it just simply gets their applications in nice and early. That was just on December 1st. So congrats to any of you that applied that way. We're working very hard to get those decisions out to you as soon as possible. For any of you seniors that haven't applied yet, you can absolutely still send in those applications, whether it's the common application or one of our UMaine applications on our website. No matter what way you apply, it's completely free. We won't charge you anything. We want it to be as easy as possible for you to apply to UMaine. In addition to that application, make sure that you send in your official transcript from your high school, as well as one letter of recommendation from your guidance counselor, a teacher, a coach, someone who can tell us a little bit more about you as a student. And of course, we'd love to see an essay as well if you would like to send one that tells us a little bit more about you outside of the classroom and as a person overall. For any juniors or lower students, please enjoy the tour today. If you have any questions about UMaine, if you'd like to come up and see the campus when hopefully we can reopen our campus tours, you can go to our admissions website at go.umaine.edu, and we have all kinds of tour information as well as lots of other things. Again, thank you so much. We're so excited that you are interested in UMaine, and I will hand it back off to Dana.
Thank you, Brittany. That was a great description about some of the things outside and around campus. This is a great, great place to be. I've been there for 35 years now, and I just love the place. What we're going to do is we're going to take a walk down the other corner here. We're going to take another look at the construction site. Now, when you're on a construction site, you need to be paying attention to what's going on around you. You can't assume people without the operator to see you. So follow me down this way here. just want to point out what we've got going on right here. This is the gravel pad where the crane's going to be coming in tomorrow to be set up. It's going to be set up tomorrow. They'll have a crane inspector come inspect it. Next week, we're going to continue on with placing structural steel. If you kind of look out this way, you kind of get another view of the steel that's already been placed. The reason that that's in place is that comes up through that concrete slab that's over the basement. So you have the steel in first before you can put it in the basement. They're doing the final steps here of leveling the gravel pad. Let's take a walk up this way. We're actually going to take a walk right out this way. See, well clear where he's working. Okay, and final view of the construction. Earth backfilling down here, waterproofing on the foundation walls. Now what we're going to do is we're going to go to the building next door, which is Crosby Lab, which is where the mechanical engineers hang out. Then we're going to give you a tour of that lab. So follow me as we head to the mechanical engineering lab. Thank you.
Leave it on the rail and up here and we'll grab it.
Yeah, and I'll need to see you one more time, Brittany.
Oh, okay.
Come on in here. All right, let's see where we can. Hey, Alex, how you doing?
Very good, very good.
You're live on the internet here.
Oh. This is right here.
Okay, excellent.
Hi, Dana.
How we doing?
Doing great.
So we have Masood and Alex.
Yes.
Masood is chair of mechanical engineering. Alex is one of our great faculty members here. Looks like got Steve lined up off the camera here, and he'll come in just a moment.
Yes.
I'm going to turn it over to these folks here, and they're going to tell you about the great things we have going on in mechanical engineering. And
Well-
you'll see me again at the very end.
Sure. Well, welcome. My name is Masood Reis Rohani. I'm professor and chair of mechanical engineering. It's a pleasure to have you. So what we're going to do today, we're just going to walk around Crosby Lab to tell you a little bit and show you some of the activities that we do in this lab, both in terms of academics as well as research. So I thought it would be great if our first stop is talking about what our students do in their senior capstone class and the capstone projects that they do. So let's go ahead and let me show you. So let me introduce you to Dr. Alex Fries. Dr. Fries is an associate professor in mechanical engineering. He's also the principal instructor for the capstone course. So with that, Alex.
Thank you very much. Hi, everybody, and welcome to Crosby. This is our lab where we conduct our capstone experience. If you don't know what capstone is, it is the culminating senior experience where our students really practice engineering. They come to this lab, they have their projects that last through an entire year. We start in the fall semester of their senior year, and then it goes all the way to the spring semester, and at the end of the spring semester, they designed, built, and tested an engineering project under realistic industry conditions. So it is intended to really bring in a variety of the knowledge that they've accumulated over the previous 3 years. And what I wanted to show today is just some examples of the diversity of the capstone projects that we conduct here at UMaine. Let me say this, we pride ourselves in a very significant capstone experience. So we have a great number of projects and a great variety of projects that are linked. Some of them are linked to competition, some of them are linked to industry, some of them are linked to research, and some of them are, like most of them, are a lot of fun. So let's take a look at them. Maybe we'll just do a quick look through and show you some of the differences. This here is a hydrofoiling catamaran sailboat. This is built, or the motivation for this arose from the America's Cup, which is the world's most prestigious sail race, where the evolution had been over the past few years to design and build boats that actually don't go through the water, but that they fly over the water on wings, on submerged wings. So it's called hydrofoils right here. So we had student teams design, build, and test these over a year, and we had multiple of them. This is an older version. You can see it has a wing, a rigid wing. This is not a sail, it's an actual wing. It's made out of fiberglass. It has adjustable hydrofoils so that the ride height can be adjusted. And they were a fascinating project. So marine engineering, aerodynamics takes us to more aerospace. Drones is really one of our highlights over the last few years. We currently have, I think, 5 or 6 drone projects. This is an example from last year. We work, and this is a typical project where we work with research entities. So some of this is funded through NASA grants that we have with the forestry college to design and build drones that work for remote sensing activities. So they will fly over forested areas, they will have downward looking sensors, and they will pick up on spruce budworm infestation and so on. So we work very closely, our students work very closely with research labs that then take their projects and apply them in real life. So we find this very exciting. This is it is a drone that can fly for over 20 minutes. It has a lot of carbon fiber parts. The actual battery is missing right now. One of the really neat things that we do too is we work with a hockey team and we recycle some of the used hockey sticks that they have. So if you look at these arms, they're actually made out of hockey sticks, out of old hockey sticks, carbon fiber high-end hockey sticks. That's one aspect. We have internal competitions. This was back to the hydrofoiling theme. We thought it was too easy to design and build bicycles, so we had our students design and build bicycles that float over water. So you can see they don't have wheels. It's a traditional bicycle frame, but the design process was to come up with lifting surfaces that go underwater. And these bikes, you can get on the bike, pedal real hard, you pedal, the propeller turns, and then these bikes will fly over the water. And as you can imagine, this is quite the engineering challenge: hydrodynamics, structures, controls, and it's also quite the learning curve. So I would say it's a good time for everybody to test these things out in the university pool. We've had multiple of these that then compete at the end of the year for a prize, or the bragging rights more than a prize. More drones. This is yet another collaboration. It's an unfinished project. COVID had a word to say here as well. It's unfinished from last year. We hopefully will be able to finish it. This is a hybrid vertical takeoff and landing rigid wing aircraft, also used for remote sensing. It does long endurance flying for the forestry department. So the idea is, again, to mount sensors on it and be able to take off vertically, fly the remote sensing mission, come back down and land, and be useful in that way. As you can see, this is quite the aerospace engineering challenge. Our students that built this and designed this, they took some of the respective aerospace courses, such as fixed wing aircraft design, and it's a fascinating project. Another one, 3D printing. A lot of the parts that you see, for example, in the previous drone that we saw here, let me just showcase this. These blue parts, they're all 3D printed. They come out of 3D printers. They're made out of PLA or ABS materials. So 3D printing is something that we leverage and we use extensively here at UMaine for the capstone projects. And this is a 3D printer, so if we're going to use them, we might as well also do some work on improving current 3D printing technology. And this is one example. Normally a 3D printer has a filament of material that goes into the print head, and this filament, it's fused to position modeling, then it's kind of like a hot glue gun, and it builds layer by layer the part on the build plate. What we've had is instead of using new filament, we are actually using recycled filament here. This is shredded and recycled filament, and our students designed and built a print head that uses recycled filament to print 3D printed parts. More 3D printed parts. This is another competition that we have, an internal competition. This is the land drone competition that's been going on for multiple years. This is one entry. Our students designed and built this. There's an outdoor track and parkour that they have to go through under specific rules. And what makes this drone so special is that the whole thing, with the exception of these things, these rods are carbon fiber. Everything else is 3D printed. Even the tires on the wheels, this is flexible material, and even this is 3D printed. Obviously the motors aren't, but motors, battery, and so on aren't, but the entire structure, with the exception of the carbon fiber rods, is 3D printed. This is another project where at the end of the semester, at the end of the spring semester, we all go out. We typically have multiple of these, sometimes with other departments as well, and we go out and have a competition to see who performs best. So you can start to see the variety. Let's get real varied. This, as you can probably see, is a starting block for swimming, for the sport of swimming. Now, this is designed, built from scratch by our students. Now, the distinction here, it wasn't just, okay, we need a starting block so that swimmers can dive into the pool. We want a smart starting block. So the task was for the students to design a starting block that fulfills all the Olympic and YMCA regulations for swimming, but that would give information to the swimmer as to how good their dive is, as to how their dive into the water. That's an important part, and to be able to train with that in practice. And it's a little difficult to see, but I don't know if you can get in here, but back here we have an LCD screen that will read out the impulse. So the direction, the angle, and the strength of the dive. And this is a great tool that swim coaches and swimmers can use for swim practice. So hydrodynamics, drones, water bicycles, swimming starting blocks. Let's go into the glacial side of things. This is a project that we've developed last year, working with the Climate Change Institute. Climate Change Institute, they go out into the field, onto glaciers, and drill ice cores, which they then use to do research. So they will look at the different layers of the ice and analyze that as to CO2 content and the evolution of the atmosphere over many, many thousands of years. The problem that they have is they have to transport these ice cores out of the field to be able to take them to the lab, and that's a challenging endeavor. So we worked with them to design a ice core transport box. You can see that the walls are quite thick, and with the idea of making a box that is so well insulated that it would prevent the ice cores from melting over a longer period of time. This particular box is not, it's not just styrofoam. This is actually vacuum insulated panels are in here. They're vacuum panels that provide a very high level of insulation. And our students monitor these, and then there was a control system in here that would monitor the temperature. More cars. Back there, it's deflated now. We started off inflated. We also work with blimps. We have an annual competition where our students design and build blimps, airships that fly around a certain, there's an oval track, and we do that in one of the indoor spaces here at UMaine. And get again leading onto the aerospace side of the capstone. So in summary, these are just some highlights. We have a very diverse capstone. We typically cater to most interests that the students have, ranging from sports to 3D printing to vehicles to airplanes, boats, you name it. We work with industry. We've worked directly with industry, designing things such as self-leveling car seats that will automatically adjust when a baby sits in them. We work with research, the Advanced Structures Composite Center, 3D printing. We work with forestry to do research. We tap into NASA grants. Recently, we're working on a drone for bridge inspections. So with the Department of Transportation and one of the centers here at UMaine, we are designing and building a drone that will fly under a bridge and use synthetic aperture radar or other sensors to inspect bridges from underneath. So in summary, Capstone is the culminating experience. It's very exciting for everybody. I'm thrilled to be able to teach it and to support our student teams in this fantastic course. And we pride ourselves here at UMaine of having a diverse and very intense capstone. So that's it from my end.
Thank you, Alex. That's wonderful. So now, with what you have seen, we want to go and look at our shop where our students are actually trained in the use of various equipment. And a person who actually does a lot of the training is our lab manager, Stephen Abadessa, who, in addition to managing this lab, he also teaches our engineering graphics and CAD course. So, Stephen, tell us about what's happening in here.
Thank you, Dr. Rice-Rohani. As Dr. Rohani said, my name's Steve Abadessa. I'm the lab manager here. So you've seen a lot of cool projects now, okay? But all those parts have to come from somewhere. And this is where the magic happens, folks. So let's take a walk around and see, what facilities are available to you when you come here to UMaine. So in this corner over here, we have both MIG and TIG welding available to the students after appropriate training. We can do both steel and aluminum. We've got a very nice 4-axis milling machine over here. This is our Tormach. And we'll go down the other way, excuse me. So I know you're dying to know what these two items are, but we're gonna hold that until the end. So if you come this way, we have our lathe, very nice unit. 2 bridge ports that are available for student use. And I bet some of you guys like 3D printing. Okay, who doesn't like 3D printing? This is a monster 3D printer. This was a gift from Jackson Labs. And we are getting this fired up and commissioned. So this will be available to the students as well. Okay, so let's go back. Let's take a look at some of these other projects that we've got going on. This, believe it or not, is not an afterburning snowmobile. We took a 2006 Arctic Cat, we ripped the back seat off, and we installed 3,000 PSI natural gas. This is an exceptionally clean burning sled. This produces about 1% of the pollution of a standard sled. So we took this to Detroit. We have gotten competition wins with this. Very nice project that we did for a number of years. Up above, folks, this is our human-powered submarine. So that kind of gives you an idea of the range of projects we do here at UMaine. We do everything from this, wide carriage CNC router. This was actually student built. This was a capstone project one year. The students had to do all the background work. They had to CAD this entire thing up in SolidWorks. And then they came in and built it. And it actually runs exceptionally well. So I hope that you will, like what you see here, and I hope you'll join us here at UMaine. Dr. Rice-Rohani?
Thank you very much, Stephen. So what I like to do is come here and show you one of our cool labs. This is a very popular lab. It's called 3D Printing Club. And this is where students learn about 3D printing. And they learn about the technology, and they also help train other students in using this technology. So I want to introduce you to the faculty advisor for the club, Dr. Bashir Koda, who is an assistant professor in mechanical engineering. And he's going to introduce the captain of the club, and Dominique is going to tell us more about what they actually do in this lab. Please.
All right. Thank you and good afternoon. Thank you for watching this video. If you are, my name is Bashir Koda. I'm an assistant professor in mechanical engineering department, and I'm very happy that you are considering UMaine as one of your choice for the school. I think this is a great school to be. UMaine is investing a significant amount of resources for our student like yourself, our next generation engineers. So my research area is in manufacturing, so I can show you or tell you a little bit about what are the new toys or what are the new engineering research or to that matter, what kind of student equipments that we have here so that you can get trained and be prepared for the upcoming your career path. So perhaps you already know that UMaine has one of the largest 3D printer in the world. we build boat, we build houses. So we have a smaller version here in this lab. I have Dominic with me here. He's a third year engineering student. He's a junior, and he's just like yourself, you couple years ago, and now he's a pro. So I will not waste any more time, but let Dominic take over and then show what a student can do with this club. Thank you.
Hello. So, like you said, my name is Dominic Agnetta. I'm a third-year mechanical engineering student, and I'm the president of the 3D Printing Club. So, at the 3D Printing Club, we are really here for a resource for the students. 3D Printing Club is a really new technology, but it's really entering the industry as a new manufacturing method. One of the strengths for the 3D printing is rapid prototyping. So you can make a new design and change it a little bit and produce your part. And if there's something that you wanted to change again, you can change your design and then 3D print your part and have it the next day. That's kind of really revolutionary because usually you have to build and invest a lot into the manufacturing process in order to mass produce something. And if you do want to change something, then it becomes much more difficult. So I just want to, this is kind of our display case we have here. This is a lot of some of the things that we've been 3D printing in the lab. All of these are made by students at UMaine. One of these, I actually made this for one of my classes. I took circuits, and in circuits, they give you a lot of different electronic components. And so I designed this case, and it holds all the little components together in a very organized way. And that was just a great use of the 3D Printing Club because I was making a custom part, and I could design it exactly how I wanted it, and it was very accessible and was really easy for me to 3D print as well. So we can actually go into the lab, and I can show you some more of the printers that we actually have. These are our 4 Prusa printers. This one's actually outfitted to print more specialized materials like PETG, which requires a warm environment, so that enclosure keeps the printer warm. This one right here is one of our multi-material printers, so you can print in multiple colors. So this was printed on this printer, and you can do 5 different colors at the same time, so you can get a part with more than one color on it. This is the largest printer that we have in the lab. This printer can print 1/2 meter cubed, and right now it's printing a part for a capstone student. And then over here we have some more of our workhorse printers. Those are our Ultimaker printers. Those do a lot of the printing for capstone and for students. So we do a lot of 3D printing for personal use, just for students, but then we also do 3D printing for some classes. We have students who are taking ME 380 or 381, and in that class you'll have to take a project where at the end of the year you design and 3D print a project for the class. And so we have students coming into the lab and we teach them how to 3D print, and we get them their parts out so that they can successfully complete their project. And then seniors in their capstone teams, their entire second semester they work on a capstone project, and we get a lot of 3D printing requests from them, and this person's already getting a head start a little bit early. So yeah, that's about everything.
All right. So I hope you get a good grasp of what student will have access through. One thing Dominic didn't mention, that he is one of our he is having an internship experience with all the experience that he's gaining from here. He's working in GE. Can you talk a little bit about that, Dominic?
For sure.
Yeah.
So I know personally the 3D Printing Club has already helped me secure 2 jobs. One of those was on campus at the Advanced Structures and Composites Center. I joined this club as a freshman, and I applied there when I was a student, and I already had some previous 3D printing experience, so I did some 3D printing for the Advanced Structures and Composites Center. And then this summer, I worked at GE Power in Bangor as a mechanical engineering intern, and I also did a lot of 3D printing for them. I designed and 3D printed a plastic bearing set for a magnetic particle inspection booth. So that was also another great application of 3D printing, and that's being used in a company that is a global industry for all sorts of different things.
Well, thank you, Dominique. Thank you, Bashir. Now, one thing that we need to also consider is that we talk to our students that academics is important, that they need to pay attention to the courses that they take, make sure that they excel in whatever classes they take. That's the first thing they ought to do. But we also tell our students that they need to expand their experiences beyond the classroom. One way that they can do that, in addition to participating in clubs such as 3D Printing Club, is to participate in undergraduate research. So what I would like to do is take you to a research lab of one of our faculty members that he can talk to you about the type of research that he does. And keep in mind that our students, like you, can actually work side by side with our faculty member in doing exciting, projects that we're going to see here. So come with me. Hello. Let me introduce you to Dr. Ying-Chao Yang, who is an assistant professor in mechanical engineering, and this is his nanomaterials lab. So he's going to tell you all about what he does and the opportunities that he gives his students working with him. Please.
Hi guys, my name is Ying-Chao Yang. I joined UMaine in 2017. I focus on material fabrication and mechanics. So today I will quickly go through my lab and my ongoing research, and then my undergraduate student Aiden will talk about his project, and then my PhD student will talk about his project as well. Okay. So for the material fabrication, we have two methods. One is the chemical vapor deposition method. We have this two furnace 1, 2, number 3. So we go to really high temperature, then we can grow nanomaterials. So we use this furnace to grow, single atom layer. So this project is supported by DOE EPSCO. So we want to have these materials, and then we want to use it to do energy harvest. So that's one project. Another interesting project, we have in Maine we have a lot of biomass. These materials we can convert it into activated carbon. So after we perform heat treatment, it will turn into this black stuff. This one. Okay. So we call it activated carbon. So it's a porous structures. The goal is we want to apply this material for water desalination and kind of filter virus, bacteria, something like that. But after conversion, the pore size might be really large. So that means if we have a virus, the virus might penetrate through it. So then the strategy is we want to grow like a common tube to refine the pore size. And also my graduate students, using another method to grow some MOF metal organic frameworks. So then, Aiden, probably you can talk about your project and also your research experience in my lab. Thank you.
Yeah, hi, I'm Aiden McGlone. I'm a second-year undergraduate. I've been working with Dr. Yang for over a year now. My current research is using the active carbons that we create and growing a microorganic framework, or MOF for short, to decrease the pore size to make it a better filter for water or to filter through viruses and stuff like that. I use a hydrothermal method, which is when I take a solution based off of water and other chemicals, I put it in a Teflon container, and then I put with the carbon, and I put the autoclave in. I put it into an autoclave, which I then put into an oven at like less than 200 degrees Celsius, but it creates a high pressure environment that allows the microorganic frameworks to synthesize. Once we have them created, we can use a scanning electron microscope to see the structure of the nano materials. From there, we can use it to do different things. We can change the mixtures to change the structures, and from there, the possibilities are endless.
Yeah. So Aiden, kind of once we grow this metal organic frameworks in that pore structure, then the pore size will be smaller, and also the surface might be active. So hopefully we can reach the goal to trap, virus or bacteria, something like that. So this project is supported by the Department of Interior. It's ongoing research. So in addition to this material fabrication, we have a mechanical lab in here. So after we fabricate the materials, we want to see the real application. We have this electrochemical workstation over there, so we can analyze the electrochemical performance, to hopefully the new material can be used to for the supercapacitors and the lithium-ion batteries. And also my graduate students, Kara, is working on interface mechanics of composite. Probably, Kara, you can go ahead to briefly talk about your research.
Hi, so my name is Kara, I'm a PhD student. So here we have this small device, this is micro tester. We use this usually to conduct 3 different tests in general, like bending test, like this, or tension, or compression. So usually this one very small device, so we use for between 2 Newton to 2000 Newton. And we use very small samples, dimension between 10 micron to 20 microns. So because it's really hard to deal with these dimensions, usually we use the optical workstation, so just to manipulate the fibers and load it on this device. This device also can work in situ, like in SEM, and so on the same time we can get the test results and we can see everything during the test at each step. Usually this device can be controlled by this laptop and this small box, so we can change from test to another, and we can collect all the required data and keep it in the storage here. Yeah, thank you.
Okay, so Kara, could you come here so we can say to our future students? Yeah. So we have strong support from the department and also from College of Engineering. So we are waiting for you to join us.
Thank you very much.
Thank you.
Thank you. Appreciate it. So let's go upstairs, and I want to show you something that is quite different from what you have seen so far. When you think of mechanical engineering, one area that should come to your mind is robotics, right? Think about the Mars 2020 mission that is right now on its way to Mars, with expected landing in February 2021. So robotics is obviously a very important area in mechanical engineering. Another important area of mechanical engineering is actually in the area of biomechanics and biomedical engineering, and the projects that are ongoing there. So this lab, Biomedical Engineering Laboratory, is led by a world-renowned researcher and Professor Mohsen Shahinpour. So we need to.
Yeah, sure.
So if you would please, Dr. Shahinpour, tell our viewers what is happening in this lab and what they should look forward to when they come to University of Maine.
And of course, you see, this is the Biomedical Engineering Advanced Robotics Lab. And of course, in this lab, we have a whole bunch of robots. Even we have soccer playing robots. We have robotic surgery, and we have ophthalmic robots. But we also do have, as you can see, this is a biomedical engineering lab, so we have all these realistic human torsos to perform robotic surgery on and all that. And now what we are going to do is to demo you something that actually we teach. It's called machine learning. So if you want to take a video of that, go ahead.
Shall I play?
Yeah, go ahead. Doesn't matter. We're just demoing this to show you how it actually can actually pick up something. No, like a heart. Don't close it yet. Okay. Go ahead. Okay. Okay. Now I can move it.
So if you want to teach again, I can start teaching.
Yeah. Go ahead and see if you can do that. Go ahead.
Okay. So now it's
Can you bring it back to the home position?
Yeah. So now it's recording. If you move.
Oh, okay.
Yeah.
So it's recording. Okay. So you see, anything I do, this machine is learning. See, I do that. Just watch these. And then basically move here, and you can touch your camera. See, it's remembering all of that. This we call it machine learning. So I'm just gonna put, and let go of it. Okay, okay. You can move it to the home position.
Okay. Now it's playing.
Oh.
So it's moving to home. Home
Okay.
is now.
Okay.
So that position, you can grab the horse.
Oh. Okay. See, you remember, was doing all of that. He taught the robot to do all of that. Remember that? So we can teach a robot to actually perform a manufacturing task, make a file out of that, and mass produce. This is a very powerful robot. The reason why we are so close, because we have controlled it. It's under our control. Because if this robot hits you, it's like a car hitting you. That's how heavy and powerful it is. And okay, and we have here some nows. These are just nows robots. These are actually the world champion in robotic soccer. And the reason why we are doing that is that we were planning to actually have a kind of a robotic ice hockey. Teach them to play ice hockey. And in fact, where are the sticks? So we are just trying to teach them how to play ice hockey, but it is difficult because they have to slide.
So these are the.
These are the, yeah. Okay, can we do the robotic surgery so that you can maybe take a look over there? Are we ready? You see, we do also have robotic surgery here. This is kind of like open heart surgery, you know. And these are the end effectors that we use with these robots. You see, these are basically, look at the tip. You see how I can move the tip from here? I can actually open it up, see? See, I can open it up. See how it opens up? So basically they make incisions in the human body, kind of like that. And that incision goes through a tiny hole into the body. And there are optical fibers here where the doctor can actually see the inside and perform surgery by attaching this to the robot and by using these to suture or whatever. And these are, of course, here we have all kinds of other robots and three-dimensional printing machines, and all kinds of robots, and over there, all kinds of robots over there. You know, and oh, there it is. Okay.
So this one is having a Tai Chi pose.
Where's the song?
Oh, it's just doing the Tai Chi.
Oh, okay. It's just exercising, right?
Yes.
This shows how they can maintain their balance, you know, and It is not easy to maintain a balance. The
We
robot.
have this one.
We have some snake-like robot. We have some snake-like robot. Attack! Yeah, we would also like to talk about this eye surgery robot. You see, we had a couple of master students did that, and we're going to continue that. You see, the robotic surgical operation on the eye requires a lot of precision, meaning you're into kind of like nanotechnology. So regular eye surgeons can't perform surgery on the fovea or macula or the optical nerves and all that, because the resolution needed is in the microns. And our hands resolution is about 1/4 inch, 2.5 millimeter. We all shake, actually. So the the surgeons can do that. So we need a robotic surgery, and this is the one that we have actually devised, that this actuator moves around, moves in and out, and it's got actuators to perform on the eye.
Move the robots. Like the way that
Yeah,
it's
go ahead.
it can have different angle.
Yeah, because it is kind of in the middle of, we were repairing it a little bit.
On the eye.
So this is a very sophisticated robot. No other university in the world has an ophthalmic robot, robotic surgery for the eye. We are the pioneer in that. In fact, we have actually published papers on it too. So this is and here is what we call a robotic surgery. How much time do we have?
I think we are almost done.
We're almost done, okay. But anyway, here we basically perform open heart surgery by robots, but assuming that you can go through an incision into the body and with optical fibers, sit inside and perform surgery.
Well, this is all exciting. Thank you very much.
Oh, sure, my pleasure. I hope it was satisfactory.
Thank you, Hassan. This is fantastic. Thank you.
Thank you very much. Thank you. Take care.
So let's go down as we are coming to the end of our tour. We're going to go down, and we're going to make a quick stop on our way out, and we're going to see one of the other projects that our students are heavily involved in, and it has to do with Formula SAE. This is a competition where students have to design, build, and race cars. So right here is an example just showing you the extent of activities that our students can engage in. So we want to make sure that our students have a holistic educational experience, one that goes beyond the classroom, and the opportunity to be involved in national competitions and give our students that added bonus, that added feature that gives them the competitive advantage when it comes to getting a job after graduation. So with that, we are coming to an end of our tour. Thank you for joining us, and we look forward to seeing you at the University of Maine. Dana?
Thank you, Mr. That was a great tour. Appreciate it. So thank you, everyone, for joining us this afternoon for this live tour. We'll have another tour 2 weeks from today, which we're going to focus on the Department of Chemical and Biomedical Engineering. And of course, we're going to start on the Ferland Engineering Education and Design Center construction site. So as you think about UMaine as a place to earn your engineering degree, keep in mind a couple of things. Number one is there's a tremendous demand for engineers. This state, this country does not have enough engineers, so the fact that you're thinking about engineering as a career is just outstanding. We have a very hands-on program. We have 11 different degrees that we offer you. Our placement rate is 99% or better, and that really indicates the demand for UMaine engineering graduates in the workforce. With that, thank you so much for joining us today, and I hope you have a great day.